In this video, we'll be talking about how to find the zeros and x-intercepts of quadratic functions, which will help us graph. So the first thing we're going to talk about is what is a zero of a function. So zero of a function is simply an x value that makes the equation equal to zero. Okay? And if the zeros are real values, meaning that they're not imaginary, then it is also a place where the graph crosses the x-axis, or their x-intercepts. So when we're talking about in the context of graphing, we're trying to find the x-intercepts here. So if you take a look at these pictures, you'll see two examples on the left and the right where we can see the zeros of the graph are these places where the graph touches the x-axis. Okay. You also see the other important point that we already talked about, which is the vertex. So these 3 points, the vertex and the zeros, are very important for the graph. And if we can get those 3 points in the right place, then it's really going to help our graphs to be very accurate. Let's do a little practice of identifying the x-intercepts given the graph. So let's take a look at example A. If we're looking for x-intercepts given a graph, we're just looking for those points where the graph is crossing or just touching the x-axis. And as I write my x-intercepts, I always want to write them as ordered pairs. So it's always going to be an x value and then a 0. Okay. Don't forget your parentheses around your point as well. It's also very easy to tell from a graph whether the a value is positive or negative. In example A, since the parabola is opening up, a is positive. All right, let's jump to example B. In example B, I'm looking at this point right here where the graph is touching the x-axis. And you'll notice that in this example, there's just one place where the graph touches the x-axis. And it happens here at 5, 0. And since the graph opens down, a is negative. So most of the time, you're going to see quadratics that touch the x-axis twice. They have 2 x-intercepts like in example A. And it's not uncommon to see quadratics like example B where they just touch the x-axis one time. And if you jump to the next example, C, you'll see that in this example, there are no x-intercepts. There's no place where that quadratic touches the x-axis. So in this case, you would say that the x-intercepts are none. Okay. So basically, your 3 options are 2 x-intercepts, 1 x-intercept, or 0 x-intercepts. And in example C, we can still say that the a value is positive because that parabola is opening up. Okay, let's do this last example here. We have 2 x-intercepts here, negative 3, 0, and 3, 0. And a is negative because the parabola is opening down. Okay, so hopefully we're feeling comfortable finding and writing x-intercepts given a graph. Now let's talk about how we would find our zeros and our x-intercepts using just the equation. Okay, there's really just 2 steps here. The first is to change your y or your f of x to 0. So that basically means setting your equation equal to 0. Then you're just going to solve for x. You want to know what x value makes my equation equal to 0. Now this second step usually requires a little bit more work than the first step. Okay, so based on what form your quadratic is in, you're going to take a different approach to the problem. So if your quadratic is in factored form, you should be happy. Factored form is the easiest way to solve for x. So you're just going to look at each set of parentheses or each x value and say, okay, what does x need to be to make that set of parentheses equal to 0? Okay. If you have an equation in standard form, you have 2 options. You can either factor or attempt to factor the quadratic, or you can use the quadratic formula that we learned previously. And if you forgot what that was, go ahead and check your notes or just type it into Google. And then finally, if you're in vertex form, then you can solve it by taking the square root. So you're going to want to get the perfect square by itself and then take the square root of both sides. Just don't forget your positive and negative sign, like a lot of people do. Okay. So once you've followed one of these 3 steps, then you're going to get either 1 or 2 answers. If your answers are imaginary, so that means that there's like a negative underneath the square root, so you have that nice letter I or number I in your answer, then the graph doesn't have x-intercepts. It still has zeros, but it doesn't have x-intercepts. Okay. Let's take a couple looks at what this is going to look like. So my first step when I approach an example, like a problem like example A, f of x equals x plus 1 times x minus 1, the first thing I want to do is I want to decide what form it's in. And this one's in factored form. Let's talk about the direction of opening. For the direction of opening, I just look at A, and in this case, the A is 1, which is positive, which means it's going to open up. Okay. Now I want to find my zeros. So this is in factored form, so I'm just going to take each of my factors. I'm going to set them equal to 0. Okay. And I'm just solving for x. So one of my zeros is x equals 7, and then another one is x equals 1. So when I write my zeros, I'm just going to write them as these numbers. So x equals -7 and 1. Okay. Then, since -7 and 1 are both real numbers, I am going to have some x-intercepts. And when I get to the x-intercepts, I want to write these as points. So I know that when I start graphing, those are 2 points that I can actually plot and draw on my graph. Okay. All right, so that's how you would handle a problem if it's in factored form. Let's take a look at B. So the first thing I'm going to look at with B is what form it's in. And since I don't have any parentheses and I've got 2 x's in there, this is in standard form. My A, remember, is this value in front of the x squared, which is negative, which means that the parabola is going to be opening down. So now I need to solve this equation. Y equals -4x squared plus 2x. So I'm going to start by setting my equation equal to 0. And then to solve this, I'm going to use the quadratic formula. So I'm going to identify A, B, and C. So A is -4, B is 2, and C is 0. Then I'm going to plug this into the quadratic formula. And again, if you forgot this, you're definitely going to want to look it up. And I will put it on the board whenever we take tests or quizzes. So x equals -b plus or minus b squared minus 4 times your A value times your C value all over 2 times your A value. Okay, then you're just going to go off simplifying this. So we've got -2 plus or minus, that whole square root just turns into the square root of 4 over -8. Now I know the square root of 4 is just 2. So I have -2 plus or minus 2 over -8. Then I want to split this problem up into the positive version of this and the negative version. Okay, so if I simplify the top fraction, -2 plus 2 over 8 is going to just turn into 0 over -8, which is just 0. And then on the bottom, I've got -2 minus 2, which is -4 over -8, which simplifies to 1/2. So my two zeros are x equals 0 and x equals 1/2. Okay. So since my zeros are real numbers, meaning that there's no I in them anywhere, I'm going to write these as ordered pairs. So 0, 0, and 1/2, 0 are my two x-intercepts. So I could start graphing those if I wanted. Okay. Let's take a look at, oh my goodness, sorry, that's zoomed in a ton. So we've done an example of finding the zeros in factored form and one of finding the zeros in standard form. Let's take a look at what it looks like to find the zeros in vertex form. So in C, I'm looking at an equation in vertex form. My A value, which is this -3, is negative, so my parabola is opening down. And then let's go about solving this equation. I'm going to set it equal to 0. And then I'm going to solve this using square roots. So the first thing I have to do is I have to get this thing that's being squared, the perfect square, that I just put in a blue box, in a green box by itself. So I'm going to start by subtracting 27 from both sides. So I get negative 27 equals negative 3 times x plus 5 squared. I'm going to divide both sides by negative 3 to get rid of the negative 3 in front of the parentheses. I'm left with 9 equals x plus 5 squared. Since my perfect square is now alone, I'm going to take the square root of both sides. Okay. So on the right side of the equation, I'm just going to have x plus 5. And then on the left side of the equation, I'm going to simplify the square root of 9, which is just 3. And I'm not going to forget the positive and negative 3. Okay. Then at this point in the problem, I'm going to want to split it into two different problems. I'm going to have negative 3 equals x plus 5, and I'm going to have positive 3 equals x plus 5. And I'm going to want to solve both of those. So I'm going to subtract 5 from both sides, so I get negative 8 equals x, and I'm going to get negative 2 equals x. So those two values, negative 8 and negative 2, are the two values that make my equation equal to 0. So they are my two zeros. And since they're both real numbers, we are going to write them as x-intercepts. Okay. So that is 3 examples of what it looks like to find the zeros of a function. Now, what I want to do really fast with example C is I want to show you how this is going to help us when we start graphing. So I'm just going to go ahead, sorry, I'm kind of taking up the space for example D, so you might want to draw this somewhere else. Let's say I wanted to begin sketching the graph of the quadratic in C. Then I know a few important things. I know that my x-intercepts are negative 2, 0. So I have an x-intercept right there. And then I have another x-intercept at negative 8, 0. So let's see, that was 2, 3, 4, 5, 6, 7, 8. So now the graph has to go through those 2 points. And I also know the parabola is opening down. So just given those 2 points and that fact that it's opening down, I can draw a somewhat accurate graph of what that's going to be. It has to pass through both of the points, and then it's got to be upside down. Now, if I wanted to make this graph even more accurate, I could go ahead and figure out what the vertex is, what that point is exactly, and then I'd be able to draw an even better graph. But that's why finding these x-intercepts and zeros are helpful to us. Okay. I'm going to jump down, and we're going to do an example of one that has imaginary zeros. So we're going to look at example F, and I'm actually just going to find the zeros for us. It's in vertex form, so I am going to solve it using square roots. So I'm going to set the equation equal to 0, and then I'm just going to start trying to get that perfect square by itself. So I'm going to subtract 8 from both sides. So those 8's cancel out. Then I'm going to divide by 2 from both sides. So I have negative 4 equals x minus 2 squared. Now I've got the perfect square by itself, so I'm going to take the square root of both sides. So on the right side of the equation, I'm just going to have an x minus 2. And on the left side of the equation, since I have a negative underneath the square root, I'm going to have an I in my answer. And the square root of 4 is 2. So then the square root of negative 4 would be 2i. And I almost forgot, one of the most important parts is that I have a positive and a negative 2i. Okay. I'm going to continue the problem up here. Again, I want to get that x by itself, so I'm going to add 2 to both sides. And I'm going to get 2 plus or minus 2i equals x. Okay. So these two numbers really are my zeros. I have x equals 2 plus 2i and x equals 2 minus 2i. Now, since these numbers, both of these zeros are imaginary, it means that I don't have any x-intercepts. Okay, so I'm just going to put none. Don't put 0 or anything, just put none if there's no x-intercepts. So as I start thinking about drawing this graph, I'm going to need some more information about it, because all I know is that it doesn't cross the x-axis. So it could be somewhere up here, could be somewhere down here. I'm probably going to need to find the vertex to figure out what that one's going to be.